Good afternoon, everyone, and welcome to the Coastcare. Welcome to Coastcare Week, and welcome to our first session that we have on today, which is where the river meets the sea. So if you do have your questions, you can put them in the chat. I can see that some of them are coming in at the moment. We will be able to go through those questions throughout the session as well. So please have some ready from your students and from your classroom. So my name's Karen from Australian Environmental Education, and today, as I mentioned, is Coastcare Week. We're running a series of programs at 2 p.m. every day this week to recognise the significance of everything to do with the coast. So we're looking at impacts on land and how they affect the water in the session today. Tomorrow there'll be a session on plastics in the ocean, and Wednesday we are looking at the deep blue ocean, Thursday marine life, and then on Friday looking at a beach survey as well. We've got someone that's having a birthday today as well, so happy birthday to you as well. So today I'll be looking at a few different slides. We'll be sharing some information. I do have a few experiments that I will be doing here today, and there's information I've shared with you and your teachers about some experiments that you can actually do back in the classroom as well. So the session today, as I said, is called From the River Meets the Sea. So it's looking at what we do on land and how that might affect not only our marine environments, but also just our aquatic, our freshwater environments as well, and how those environments are connected. So we'll get started. I'll just share my screen and we'll go from there. I just want you to be thinking about, no matter where you are across the country today, whether you are near the coast or further away, that our impacts do spread quite widely. About 85% of the Australian population live within about 50 kilometres of the coast. So we'll be looking at the impacts within what we call catchments and where they're flowing, where catchments are in Australia, and we'll look from there. We've got a couple of people. The session's about 40 minutes long, depending on how many questions that you've got. If there's lots and lots of questions, we'll stay on for a bit longer, but if there aren't any questions, then we may even finish a little bit early. So when we're thinking about water, it's important to think not only about our marine environments, but also our freshwater environments as well. So the Earth is covered, about 75% of the Earth's surface is covered by water. And of that, 97% is oceans, is our marine environments. There's only 3% of water that is actually accessible fresh water. And that's caught up in things like glaciers, groundwater, lakes and soil moisture, and even inside living things. So not all of our water is available. And we have water flowing from our freshwater environments into our marine environments. And if you haven't seen this before, it's called the water cycle. And the water cycle is the movement of water through the environment. So we have our sort of evaporation from surface water or the surface of the ocean, and it goes up into the atmosphere. And then we've got transpiration as it moves through the atmosphere. Precipitation is when it rains back down. And then we've also got that infiltration where it either soaks into the ground or flows across the surface back into the lowest part of the environment. And we call that part of the catchment. So depending on which side of the highest point in an environment the water flows, it will flow one direction into one catchment or the opposite direction into a different catchment. And that can be very important, thinking about in your local environment where the water is flowing. So catchments can be quite small, linking to one stream or creek, or they can be really big. So if we look at a map of Australia here, you might be able to identify which catchment you're in. Now, if you're based anywhere in southern Queensland, middle of New South Wales and Victoria, we've got this very, very large catchment, which is called the Murray-Darling Basin. And everything from the Great Dividing Range to the west flows into the Murray-Darling Basin. And eventually that flows into the sea right down in Adelaide. So the Murray-Darling Basin takes up about 1/7 of the Australian landscape, but everything that's on the east side of the Great Dividing Range flows directly into the catchments into the ocean. And if we look at our population graph of Australia here, we can see the blue there. So along the coast, we can see it is certainly bluer than a few of the black dots in our capital cities, but the majority of Australia has a very, very low population. So a lot of the impacts we have are on the coast, where people are living, where people are changing environments due to things like habitat destruction, or where land reclamation, where we're actually removing certain habitats and creating more land spaces. And all of those areas do have impacts on our environment. So one of the things that's important to understand is some of the properties of water. So this one here, we've got surface tension. Now you can do this experiment by filling a glass of water up and maybe looking at when it gets right to the top that it's actually slightly raised over your glass. You can either try to balance a needle or a paper clip on that water as well. And it's linked to surface tension. It's linked to the H2O molecules and how they're attracted to each other. And it's one of the important ways that we have lots of our light animals, like this water strider. And if you can notice that behind me, the water spider, how they can actually walk on water. They're light, they spread their weight around, so they're not impacted by the surface tension. So these things are really important when we understand impacts in our environment. So we have our catchments where water flows to the lowest part in that environment. So everything that it's picking up on the way ends up into the lowest point, which could be a creek, a dam, a lake, and eventually the ocean. So everything like oils, detergent, sediment, animal poo, all those things get washed in to those environments, and they can have impacts on the water. So when we're looking at surface tension and the ability for those animals to walk gently across the water, that's impacted by something as simple as detergent. Detergent breaks the surface tension of the water. Now, when you're doing the washing up, that's really important. That can help break down all of the dirt on your dishes. But in the natural environment, too much detergent breaks the surface tension, and it means some materials will mix in the water better than they would before. And it also means that the ability for those animals to stay on the surface is broken down and they can't live the same way. Now, I've got a little experiment here, which is looking at oil and water. So in this bottle here, I've got food colouring and water at the bottom and oil at the top. We can see, hopefully I won't leak, that it doesn't really mix. When I turn it upside down, we've still got the bubbles of water sitting separately to the oil, and now they're settling back down to the bottom. So even if I shake it a little bit more, make sure you've got your lid on very tight if you're doing this one, we can still see that the water is bubbled inside the oil. And as it settles back down, it'll separate back out. But I mentioned that detergent has an impact on how different things mix in the environment. So let's see, I'm going to add some detergent to my bottle. If I hold it up, the detergent has dropped straight down on my layer between my oil and my water. Now I can see that it's slightly yellow. I'll put a bit more in so you might be able to see that layer. As it sinks, you can now see a yellow layer forming in between in the bubbles. So making sure my lid's on nice and tight again. I'm going to turn it up and shake it again. So straight away, we can see that the barrier in between is gone. It's still separating out a little bit, but it's certainly mixed a lot more than it had before. Now, remember, I'm not shaking it a lot, really just turning it upside down a couple of times. So these kinds of impacts in our environment, when we have things in our water that we're not expecting, can make changes to the whole, what we'd call the water column. So we're mixing, so our oil now and our detergents have both mixed with our water, and it's much harder to separate once they're mixed in there. But it's not just things like water and oil and pollution that end up in our waterways. There are lots of bigger things as well. So we're going to, in a moment, have a look at sediments, and we're going to look at sort of rubbish as well, so bigger pieces of material. Now, in the notes that I've shared with your teachers, there's an activity called the Story of Water, and this is a really fun and interesting one to either do at home or in school. It's a little bit fiddly. You need lots of different little jars of containers, but to represent different materials in an environment. So imagine up in the upper catchment, if you've got a big catchment, there could be a national park, a natural environment, but there could be lots of people going four-wheel driving and dirt biking, causing lots of erosion. So when it rains, that extra sediment washes into the water. You could have an area that's got lots of agricultural and farming environments, and it may be that there are pesticides and fertilizers that wash into the river or the catchment when it rains. There could be areas where there's lots of industry and there's lots of rubbish and mess, or people dumping, illegal dumping of rubbish. That physical big material can also end up in their waterways. We also, unfortunately, have lots of people that do illegal dumping. And it could be a drum of oil or pollution that was dumped 20 years ago that's now rusted, and that's now leaking into our environment. So by doing some activities, getting a nice bucket of clear water and then pouring different things in depending on what is happening in your environment. So you can easily get a land use map of your area and working out what kind of industry, whether it's urban, agricultural, rural, industrial, and having an idea of the different things that could end up in your waterways. Just bear with me, I'm just checking on the questions. Oh, good. Yeah, a few people could see the detergent separating out when I used a little bit more. That's excellent. Okay, we'll go back to our shed. Having a think about how oil ends up in our environment. So oil's got direct and indirect impacts, as I mentioned before. So some of the direct impacts, of course, are going to be covering animals or animals getting coated in oil, and that can have an impact on their fur and their feathers. Things like frogs can have an impact of how they can breathe through their skin, can impact directly on lots of small organisms as well that essentially then can't fly as well. But some of the indirect impacts, like I demonstrated there with the mixing of the water and the detergent, that is also a factor in the environment. But oil ends up in our environment in many different ways. There are natural sources where oils are leaking out naturally, but also extraction of oil and petroleum, transporting. Unfortunately, a lot of our oil spills happen when either directly from the oil rigs, but also transporting oil from country to country. But it does happen running off from land as well. So hard surfaces pick up lots of oils and wash them straight into the environment. There is a little bit of oil from aviation and also from air pollution as well. And here is a spill. We can see on the water here, the physical oil hasn't mixed through the surface, but if any animals swimming through that or coming up from the surface, aquatic animals to breathe, will get impacted by that oil as well. And there are many ways that you can remove oil from the surface. Some of it is physical removal, but they're looking at lots of biological ways that they can now remove oil from the environment, which is really important as well. What are two things water is made from? Well, that's what we mentioned before with the molecules, the H2O. So it's the hydrogen and oxygen atoms making the H2O molecule. When we have lots of big storm events as well, it's not only some of the small things like oil and pollution that are mixed through. You'll probably notice if you go to your local park or local wetland that when it's not a stormy event, that you may just have relatively clear water. But after storms, it becomes very murky. And that's what we call turbid. And the turbidity of the water is the cloudiness of the water. And that has an impact of how sunlight can get through to some of the aquatic plants as well. And it also affects the animals and plants being able to get dissolved oxygen in the water. Sometimes that murkiness or the turbidity is made up of clay, sediment, sand, sometimes your oils and pollutions and fertilizers. But a lot of the other things that wash through the catchment after a big storm is debris. So we can see here, this is my local park after a big storm. It's generally quite flat and it's really in the middle of a big urban area just on the way to Parramatta River in Sydney. What we can see is lots of sticks and branches, so much so a really big tree has actually blocked the bridge and everything after it has been dammed. So lots of sediment and material affected by that. But if you look closely, we can see plastic bags wrapped around some branches and water bottles as well. So anything that floats moves through the water and can get trapped. So we often will find small things like pen lids and plastic tops, plastic bags, and a lot of plastic bottles. So 80% of the litter that ends up in our waterways is plastic rubbish from bottles, wrappers, food wrapping, and ultimately, if it's not blocked or stopped, it will end up all the way into the oceans. And what happens with plastics, as they're bouncing and rubbing together, they break down into smaller and smaller pieces. And you may have heard of microplastics before. We've just got a question here. What happens when the animals swim into oil? So it depends on the animals, whether or not how they will be impacted. Animals that don't need to come to the surface to breathe can potentially just avoid it. By the time they swim through the water, they may actually not come in contact with it. But birds, reptiles, and marine mammals need to come up to the surface to breathe, or they're floating on the surface. So they are absolutely directly and physically impacted by that oil. And it can affect their ability to fly. So birds, the oil affects their ability to fly. With marine mammals, if they've got fur like seals, it actually affects the ability for them to stay warm because the oil impacts on the oils in their fur that helps them stay warm. Other animals may be impacted by part of their food chain. So the food that they eat isn't available. So it can have a big impact. Another question we've got here, how is algae bad for the water? So we often will hear things called algae blooms, and those are when the chemical composition of the water and the environment isn't right. So what can happen with an algae bloom is that there's too many nutrients in the water. This is often happening by runoff from land. So if there was fertilizers or nutrients in extra erosion in the sediment and more nutrients, then the algae has more food and energy and they increase in number really rapidly. And it means that there's not enough predators or to be able to eat that algae to keep it in a natural balance. So algae blooms can happen both in marine environments and freshwater environments, and it's an imbalance between the really as part of the food chain, but also too many nutrients in the environment causes that more algae to grow before there's enough animals or other plants to be able to take it up. So we often will get algae blooms. There are lots of different kinds and they're often different colours as well. So that can be an impact. I can just see a couple of other questions down there as well. Sorry, bear with me. What happens if detergent or other substances like that mix with salt water? That is a great question, and that could be an experiment that you can try as well, using fresh water, maybe colouring it with food colouring blue, and maybe do salt water, colouring it with yellow or green or another colour, and doing that same experiment and seeing whether the salt has an impact on how it's mixing. Certainly, oil can mix up in marine environments as well. I'm not sure whether the salt does have a big impact, but that's a great one to try. Isn't algae seaweed, and is seaweed good to be in the sea? Oh, that is an excellent question. Thank you for that. So there are different kinds of algae, and certainly seaweed is a kind of algae. So some of them are really, really small sort of individual ones, and the big ones like the brown seaweed is a much, much larger form. And it does depend. Anything that ends up in a different place than it's supposed to be can essentially become a weed. So there are even some places that if you've got it in a natural environment, you absolutely want this algae or seaweed, but if it ends up in a different environment and it can take over, it can then choke oxygen out of the water as it's growing and have those impacts on the marine species. So too much algae in one of those algae blooms is also, choking the waters, taking the oxygen out of it, and it means that a lot of the animals living under the water get impacted, especially if it's a closed environment like a lake or a dam. When it's in a big marine environment, often with the tides and currents, things can get spread further afield, so it doesn't have as much of a localized impact as it can, say, in a freshwater environment. But yes, algae, lots of algae, very, very important to the environment, very important to parts of the food chain on both freshwater and marine environments. So we absolutely do need it. And it's when those algae blooms are those imbalances in the environment. Is there a reason why fish can't swim well in oil? Because the oil gets in their gills. If it's going through the water column, absolutely, it's going to affect that. But if a fish is coming to the surface and it's trying to get food or things like that, it will get impacted by the oil. And you can often see them sort of gasping for fish, for breath. And often with these situations, oil ends up sort of choking the water. So it does sometimes mean that it causes a low oxygen environment, and that's when you often will see the fish gasping as well, because there's just not enough oxygen in the water, whether it's from an algal bloom or from oil spills. Great questions, everyone. Let me see. I think there's one more. Does oil have an effect on ice on rivers and lakes? Again, that is another great question that could be a good experiment. So essentially when water freezes, it's most likely it's just the water part of it's freezing. So the oil, it may well then it separates out again as well. But I haven't tried that one. I'm going to give that a go as well. Can't big sharks just swallow small rubbish without being affected? You often will find large animals absolutely eating bits of rubbish and plastics. And there's various impacts that you'll have. So one, a lot of this rubbish has no nutrients, no energy value to those animals. So what that can mean is they're just not getting any use from it. So if they eat lots of things that don't have energy, they'll end up essentially starving. So it is important that these animals are getting healthy, nutritious food. So sharks are certainly, as a big animal, do tend to just eat, often are called garbage guts. There's a few kinds of sharks that will end up with all sorts of things inside. So as long as they can still eat large food, that will still help. But what we find, and this has certainly been seen numerous times with seabirds, is they eat so many bits of plastic and rubbish and they can't pass it through their body. So they can't digest it and break it down. So they're not, a bit disgusting, but they're not pooing it back out of their body. So their stomach fills up with more and more and more bits of plastic, and eventually they starve. So I've seen a skeleton of a bird, a shearwater, and essentially where the stomach would have been was just a pile of plastic, bread clips, little bits of pen lid and plastic lids, just hundreds of small pieces of plastic, up to about 10 centimeters in size. And essentially the animal starved because their body had been filled up with bits of plastic. So it's a really big impact there in terms of entering the food chain. And so if you've got, say, this bird that's eaten all this plastic and then it gets eaten by a bigger animal like a shark or another bigger bird, their stomach then ends up having lots and lots of plastic in it. And over time, the food chain gets very affected by all of these pieces of plastic. They're finding microplastics in some of the zooplankton, some of the really, really, really small, building blocks of the marine food chain, and they're still finding small bits of plastic. So once it's in the environment, it can have massive, massive impacts. Excellent. Okay, let's have a look back through our slides. Where were we? Okay, so not only do we have those big things, like we were just talking about, all those bits of plastic, we also have sediment and nutrients. So this is an example up at the Central Coast earlier this year, where we had some really big heavy rains on mainland. And this is one of the sort of coastal estuaries or lakes draining. So we can see our beautiful sandy beach and our beautiful blue water. And what's behind it would usually be quite blue as well, with all of the sediment that's coming from land. Now, remembering this was probably one of the really big floods after the bushfires that we had throughout Australia. So what that meant is there wasn't as much vegetation protecting the soil. So when the rain was coming, lots of sediments and nutrients were washed straight into the water. And we can see it pooling out and that murkiness. Now, if you might remember, we called that turbidity. So the turbidity of the water is the cloudiness, and that can have a lot of impacts through the environments. So with the marine environment here, eventually that's going out to sea and it's settling down. So as long as there's not as much energy, it will actually settle out of the water. Now that is a good thing, depending on what is in those sediments and whether it then will choke seagrass beds and mangrove environments when that sediment finally settles, and how many impacts that might have on the marine animals on its way. But it is a really important visual representation that all along the east coast of Australia, our biggest storms after the fires were having plumes like this at every beach and estuary, pretty much all the way up the coast of Australia. So it's not an isolated incident. It would have been happening everywhere. And of course, it would have been happening on the other side of the mountains as well. All of that sediment was washing into creeks, lakes, dams and rivers, no matter where the catchment was flooding straight out to sea, or whether it was washing towards the Murray-Darling Basin. And then that, of course, was having flow-on effects. So we were seeing fish kills and all sorts of things happening from a lot of this heavy nutrient material washing into the waterways. So up in the Great Barrier Reef, one of the impacts that they do have is sediment washing into the coral environments, and sometimes the sediments are actually blanketing the coral reefs and affecting, again, the nutrients, and are affecting that sunlight being able to get through to the coral. And it's happening from various things. It's happening from bushfires, as we mentioned before. It's also happening from land clearing, heavy agriculture, and the removal of mangroves. So a couple of the activities and information I shared with you earlier today is all about mangroves and estuaries, and the importance of these areas to slow down water, because when water's moving slower, that's when the sediment can drop out instead of it making it all the way out to sea. We've got a question as we're going as well, is do oil make rivers and lakes black? Not necessarily. So sometimes if it's a slick oil over the surface, it might look reflective and black, depending on the type of oil, whether it's sort of that dark petrol colour, or whether it's a lighter oil. But sometimes those environments are black because of the sediments. There's a few different reasons, so not necessarily oil. A few of the different ways that different pollutions are getting into our environments are from coming out of the atmosphere. We have it all the time when it's raining as well. If we've had big dust storms, when it rains, that settles out into the environment. And remembering, anytime it's raining, it's going to the lowest point of the catchment, whether or not that is in our lakes, rivers, or directly into the ocean as well. Coming from humans, so it might be animals, dogs, cats, but also lots of agriculture animals doing poos, then washing into the water. Construction, a lot of construction involves removing trees, which can have an impact on runoff as well, and also digging holes and things like that. So you might notice a lot of construction sites will have sediment protection. So when it rains, it's collected into the building site, unfortunately, not always successfully. But also thinking about our drainage surfaces. Hard surfaces make water move fast. So if there's lots of roads, lots of footpaths, lots of car parks and concreted areas, the water is going to move faster into stormwater channels and ultimately into the water. So green spaces can often have a really good effect by slowing things down. We have a look at this one here that I came across today, which is really good, is the idea of these green filters and grey funnels. So it's a great way to think about it when you might be doing a bit of a catchment audit or just having a look around your local environment. How many places where your wetlands are, like your creeks and your streams, are linked to green spaces? The more green spaces there are, the water can soak into the ground. Whereas lots of areas with those hard surfaces, grey funnels, mean the water is going to move really quickly down gutters, down stormwater drains. Now, this can be very important in urban areas, so you don't get flash flooding. But it also means that the water is moving very quickly, picking up rubbish, pollution, oils, and it's going directly into stormwater channels. And if that doesn't end up being sort of caught and slowed down before it ends up in bigger rivers or the ocean, all that material goes straight with it as well. Let's just grab a couple more of your questions. I might just stop sharing there for a moment. What does petrol do to the water? Well, petrol is, a type of oil. So it's the same kind of thing. It will float on the surface of the water. It's going to coat animals and impacting them directly and indirectly. So petrol will really have the same kinds of impacts. How does oil go out to the sea? Do ships go and drop them off? So a lot of the time it will be part of our, country's freighting systems. They'll have big wharfs and docks where they'll actually, load ships up with things to leave the country and also for things to come back in. So, they've got big specially designed ships to carry oil and petrol and those kinds of things all around the world. Unfortunately, sometimes they are impacted by storms and weather, misadventure, and then they can cause oil spills. And if those oil spills are out to sea, the environment can work on sort of breaking down the oil, but as soon as the oil hits land and those shallow areas or tidal areas like coral reefs, they can then coat the surface, and that can have a very big impact. How does oil become black? So I think that's all part of sort of the oil, different processing, the oil, and I think the sort of petrol side of it ends up being black. So the technical side of the oil and being black is, I don't know the answer to that one, I apologise. If we swim in beaches polluted with oil, can it impact on us? If you were seeing a beach that you could see oil coated on rocks or animals, you absolutely should not go into the water. Most of our beaches, we wouldn't physically see, they wouldn't be open. Certainly in Australia, if there'd been oil spills, they have a lot of protection of the environment in Australia, and they would close the beach until they were able to do cleans. They do that with oil spills, or if there's been sewage spills and those kinds of things as well, they'll close the beach. So you shouldn't have to necessarily worry about that. But yeah, we can be impacted by it as well. If it gets all over our skin, your pores wouldn't be able to sort of breathe and work the way. So it will be impacting on your skin. And that's large amounts of oil. Small amounts of oil, people use it for healthcare and those kinds of things. So small amounts of the right oil would still be okay for you. Okay, let's keep going. I think that was it for questions just for now. Keep them coming. Okay, so we're really focusing on that green filter idea. Just got to move that out of the way. It's the idea that we need to slow water down so it can soak in and avoid runoff. Now, occasionally we'll get things like flash floods because our ground is super soaked, super saturated, and that means that there's no more water can soak in through the soil, that there's already plenty. But most of the time in Australia, we don't get to that point, that there's still plenty of opportunities for our green spaces and environments to soak up those environments. And there's many places we can do it, including in urban environments. And it's thinking about making some small changes. So planting rainwater gardens where you're actually designing to capture the water in some spaces underneath that then can be reused in that environment, or that it's slowing it down, it's infiltrating into these rain gardens, and then it is being funneled into our stormwater environment. So it does slow it down just a bit. Replacing pavements with permeable pavers. Now, permeable pavers, a great place if you are in Sydney to have a look is at Sydney Olympic Park. You can see them a lot on the edges of parklands, and essentially it is pavers that have little spaces in between. So they're still easy to walk along, still safe, but it means that the water doesn't hit the surface and run off. It actually soaks in through into the ground underneath. You can see the same thing around lots of trees in park areas, that there might be grates that have holes in it, and that's enabling the water to soak into the roots of those trees. Other ideas could be planting rooftop gardens, green walls, and just in general planting more trees and vegetations, because that water will soak in. It helps those green spaces grow, which have great other beneficial effects for urban environments as well, but also slows down the water. And if we have a look at this one here, this is really looking at all of our different wetland environments. And we've got wetland pools like a billabong or a lake, salt flats, salt marshes, mangroves, intertidal areas, and our tidal areas. And all of these places have vegetation to slow down the water. And as the water slows down, the sediment drops out. The sandy stuff drops out first, and then things like the clay and the mud will drop out. And that provides nutrients for mangrove forests, for our salt marshes, and for a lot of our woodlands around our creeks as well. So very important. We want that sediment to drop out before it hits our marine environment. So we're not pushing too many sediments into there. So these environments are really important. Unfortunately, mangroves are disappearing all around the world. I think I had a picture. Here we go. I lost it before. There are other ways to trap material as well. So this is a great one here that's showing a physical stormwater net. Now, I've been seeing a lot more of these around. Lots of councils and lots of water companies around Australia, no matter where you live, are installing these kinds of products. And what they're doing is capturing the big stuff. So the plastics before they get into the creeks and to the ocean. Lots of those other bits of rubbish as well. So cardboard, cans, anything can be captured. Now, these are great as long as your council or water company, whichever group is doing it, will then remove these. I have unfortunately seen a few cases of these things being put in place and never being taken away again. So they get overfilled. But these physical barriers are extremely important for stopping things going into our environment. Because our wetland environments, both our freshwater and our marine wetland environments, are some of the most productive ecosystems in the world. They're comparable to rainforests in terms of how important they are as part of the food chain. They create amazing habitats for some of our smallest invertebrates all the way up to some of our largest animals. Certainly mangrove environments are nurseries for a lot of the marine species. So a lot of marine species spend part of their life cycle in the open ocean, and some of them will actually come all the way up into freshwater environments to breed. And often there are other species that will have their young living in the mangroves. So these are both invertebrates and vertebrate species that will use wetlands as an important part of their life cycle. So being able to have that connectedness from the land to the sea is extremely important for many, many animals throughout Australia. And that's why it's important for us to understand what's happening on land and how that can also impact the marine environment. So I'm just going to stop sharing there for a moment and wrap up some of our questions that are coming through as well. And to think about what we can also do to help and make a difference. So we think about these big structures that can get put in place to be physical barriers and blocking some of the rubbish and pollution that can end up in our waterways. But we can also think about how we can stop them getting there in the first place. So lots of great ideas happening at both school and home around recycling, around reducing the amount of packaging that we might have, which reduces the amount of waste. When there is waste, what we can do to upcycle it or recycle it or reuse it as well. So there are lots of ideas, and I'm sure you all have many of them as well. So it's a great opportunity to share amongst your family if you're learning from home, or share within your classroom different things that you could do at school or at home to help reduce the amount of stuff that ends up in our environment. And it could be thinking about not putting oils and detergent or food scraps down the sink. It also could be thinking about physical packaging and bottles and how you can do that as well. And I have provided lots of information about how to do a wetland audit, how to do a school water audit, even just thinking about your drains at school. You know, how much rubbish might end up in those? Are there ways for you to stop that rubbish getting in there as well? And then thinking more broadly, what could you do in your local community to let people know about being more sustainable and more environmental with their rubbish? So have a think. You might want to put a few things in the Q&A if you've got ideas about that as well, while I have a look at some of our final questions. Oh, absolutely. We've got someone that's already put in the chat, even before I had a chance to mention it, the idea of recycling, being able to, take some of the physical material out. You can do some really cool competitions across your school as well about creating art or creating, different items from reused objects that might be able to use at the school, or yes, as a sustainable art project as well. There are some great ideas there as well. So that is pretty much the end of our session today. If you have any more questions, please put them into the Q&A. Otherwise, I've shared lots of information with you, general information to help you understand more about the topic, some activities, and some really great videos as well that can link to some more experiments that you can do in the classroom or at home. But definitely understanding that where you are living is part of a catchment. Your catchment, all of the water that falls in that area will flow to the lowest point, whether it's a creek, a lake, or a stream, and ultimately it will flow into the ocean. Even a catchment as large as the Murray-Darling Basin ends up filling out and ending in the ocean in past South Australia. Lots of catchments along the east coast of Australia from the Great Dividing Range, often going straight through to the ocean. So all of the different things that we can think, how we can help those environments, are all really important. We've got Naim as part of your school council. This is a special netting over our drains to stop chip packets and rabbits getting in. Oh, what a great solution. And I love that you're looking at that as part of your school council of things that you can do. What I've been seeing in the last 5 years is so many schools really being very, very active about removing litter and recycling things, but especially those ideas to stop it then getting into the system, getting into the waterways, because that's the flow-on effect. So yeah, wonderful work there. That is great to hear. So thank you everyone for joining me today. I've shared my details with your teachers or parents, so please feel free to contact me if you do have further questions, and hopefully you'll join us for the series of events this week, and you'll be able to hear more about some of the marine environments. National Maritime Museum tomorrow talking about some of the sea bins and plastic removal from the marine environments. So lots of amazing innovations that are happening throughout Australia and across the world to really counteract some of these issues that we do have, and to try to bring back more of the natural processes of our marine environments. Last question I can see here: how can a fish swallow rubbish if rubbish is big? Great point. So some fish may actually be eating smaller things. So when plastics especially bump together, and even just other rubbish when it breaks down in the environment, gets smaller and smaller. So it may well be that it can't eat the big stuff, but over time, that rubbish and material is still in the ecosystem and it eats it when it's smaller. And that can have a big impact as well. Okay, everyone, thanks so much for joining me, and I look forward to seeing you again soon. Bye-bye.